the Andy Social Podcast, episode 216. This week's guest is Jake Clark. Jake is a freelance science communicator. He's an astronomy PhD candidate. He's a 2020 Fulbright future scholar and no doubt heaps more. He is one smart cookie. Jake and I caught up a little while ago to talk about a whole range of different things, exoplanets, astronomy in general, lots of things that go over my head completely. And right on topic, we talk about the challenges in just talking about science in everyday life to the general public. And me being one of those dills who really struggles to understand a lot of the sciences. And you'll hear me trying to grasp a lot of what Jake's trying to say in this great chat. You can learn more about Jake by going to his website. It's jake-clark.github.io. Yeah, that's a mouthful. So you can go to the show notes over at andysocial.net or andydowling.net. You should be able to click through on your podcast player as well. I'll have links to his Twitter, and his Twitter handle is SpaceJayk. And I'll also have handles to Facebook, and I'm pretty sure he's on YouTube as well. Anyway, I'll have all the links in the show notes over at andydowling.net, or you can click through on your podcast player. But that's enough for me. Please enjoy this great chat with Jake Clark.
Exoplanets are worlds beyond our own solar system. So any sort of planet that's contained within our own solar system, so the 8 that are in our own solar system, you got Venus. Oh my God, I can't even do that right. There goes me getting a PhD. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, no Pluto. There's not a planet anymore. Soz. Very, very controversial. But so they're all known as planets, and then sort of any planet that we discover outside of our solar system, typically they can orbit one star, or sometimes they can orbit 2 or 3, or sometimes they don't orbit any star at all. They're just sort of floating in free space. So all of those are known as exoplanets. And so we've discovered about 4,100 so far in the last 30 years. And so the first exoplanet was discovered about 30 odd years ago. And we've been finding more and more ever since. And now with the launch of TESS, which is the Transiting Exoplanet Survey Satellite. So it's NASA's first all-sky mission to scour the entire night sky for exoplanets. And in the last 2 years since it's launched, it's discovered 37 planets so far of that 4,100, and it's predicted to find about a few thousand, if not maybe tens of thousands of planets orbiting nearby bright stars. So there's just so much out there, and I mean, statistically out there, there should be at least one planet orbiting around another star in the night sky. And so we're looking at, millions, if not billions, of planets within our own galaxy to discover and then explore.
There's probably so many different reasons why we're trying to search for these planets. I mean, just there's so much information that would be out there that would help us. But is a big thing or is it a bit of a buzz sort of reason to try and find life?
I think for most people when they get into the field, they sort of get caught by that romance of thinking, well, maybe I could be that person to finally find ET and send him back his phone bill. But I think we want to try and answer one of the most profound questions humankind has been pondering since we've got out of the caves. And this is, are we alone? We would look beyond the hills around us, and we would go and explore beyond that hill, and then you'd go beyond those oceans. And now we've come to the point in our civilization when we can now scour the cosmic ocean and try and find out whether or not we are indeed alone, or whether or not there is life out elsewhere. But I mean, within the last 30 years, we have found planets that are stranger than most planets we find in science fiction movies like Star Wars. I'm saying that as I'm staring at Kylo and Chewie and Han in my backyard here. But I mean, we found planets that are sort of the similar size as Jupiter. Now, Jupiter is about 10 times the size of Earth, but these things are orbiting around their stars. Their years could be on the order of days or even hours. So in some cases, these planets can whip around their star in the order of, say, 10 hours. So every day there is both your birthday, New Year's Eve and New Year's Day, which would be quite the party. And one of the most popular planets that we have discovered are these things known as super Earths. And so a part of my research is to try and work out the composition of these worlds. Now, these worlds are a little bit larger than Earth and smaller than Neptune. So I was trying to work out, because Neptune's a huge ball of gas, and we think it's got a rocky interior there, and Earth is mostly made out of rock. So where's that point in which rocky worlds start to turn into gassy worlds? Can we have larger worlds that could possibly support life? Because, trying to answer that fundamental question of, are we alone, requires knowledge in biology, chemistry, physics, astronomy, geology, all sorts. And so I don't feel like it's going to take sort of one person or one research group to answer this fundamental question. It's going to take the whole field to try and answer this one specific question. And I think, we all sort of get into this field because of that. But as with all research, you sort of get fascinated by one little particular topic and then get stuck into that.
I'm thinking of every science fiction movie that I've ever watched over the years, or some episode of Star Trek or something like that, cruising through a galaxy, just coming across all sorts of weird and wonderful things in their travels. But I guess it's such a hard thing to grasp. But I guess the size of a solar system versus a galaxy and universe, and then even the arguments about multi-universes and all that sort of stuff. Because of the distances and the size that we're sort of dealing with, it's not a case that you sort of look up into the sky with a great, amazing telescope and eventually sort of come across something. this is sort of, there's an element of, there's an element of science attached to it, but it's funny that. But I guess there's some mathematics involved, and there's a lot of calculations that would be, it's sort of, I guess there's an aspect where it's theory based, where you're utilizing the information that you have on Earth and what's sort of within your grasp, and then sort of making, I guess these are theories in a way, because it's so hard to be able to grasp or really understand, to those distances of what's actually out there, and what could potentially be life, because life that we think and stereotypically with pop culture and what we traditionally think extraterrestrial life is, it could be nothing like that at all. It could be just completely different.
Yeah, and there's a lot to unpack there. So definitely we've only sort of rolled the dice once when it comes to life as we know it, and that is carbon-based life. And maybe carbon-based life is different elsewhere in our galaxy. And there's a field of research known as astrobiology, and they sort of look at, could carbon-based life live and thrive upon other worlds? There's evidence to suggest that maybe there might be some microbial life that could exist inside of the moons of Jupiter or Saturn, particularly Enceladus and Europa. There's a huge ocean of liquid water underneath their frozen crust. And so there's currently now missions that have been proposed in order to go to these moons and drill down and pop a little submarine in and check it out and see if there's any life in those moons. Now, they're not going to be that life isn't going to be as complex as, say, humans, but it might be sort of simple microscopic life. And so that's going to be hugely exciting if we do find life elsewhere within our own solar system, let alone elsewhere where you've got planets orbiting around other stars. But like you said, we currently right now trying to discover an exoplanet isn't as easy as pointing a telescope to that star and being like, hey, I found the planet. And it takes weeks, months, depending upon the method you use in order to find these planets. And so there's two main methods to find these alien worlds, and one is the transit method. And so if you close your eyes and you're in your lounge room and you have a lamp in the middle of your room, and you've got yourself sitting down sitting down on the couch, you're trying to watch TV, you've got a lamp in between you, and all of a sudden you have one of your brothers or sisters trying to be silly, and then they're sort of just dancing around that lamp pole. And so sometimes you'll see that light, sometimes you won't, because they'll be blocking the light between. You won't be able to see the light because they're blocking it. And similarly, you have a planet orbiting around a star, and the starlight will dip ever so slightly due to the fact that the planet sort of casts a shadow on the stellar surface. And so that shadow can tell us the period of the planet, and because, if you see the dip, say every 10 days, that means that the planet must be orbiting that star every 10 days. And then the dip in the stellar flux, or the starlight coming from that star, tells us how large that planet is. And so the bigger the dip, the bigger the planet, the smaller the dip, the smaller the planet. And so the other method we use is known as the radial velocity method. Now, if you can imagine being at the playground and being on a seesaw, and attached to the other end of that seesaw is this huge Asian elephant. Now, you're going to have your legs kicking up in the air, and the elephant's going to be down on the ground. And that's because the elephant is a lot heavier than you. But what we can do in order to sort of balance that system out is move that fulcrum, that wedge that you balance on in the seesaw. If you move that fulcrum towards the elephant, you'll start to balance out. And there'll be a point there where you balance out completely. And that point there is known as the center of mass. And so if you replace the elephant with a star, and you replace yourself as a planet. So, sorry, man, I lost my train of thought there, but I'll get back to it. That's what editing software is for. So you got your star, you got your planet, and so that star orbits around that point just as that planet does. And so when teachers say, "Hey, look, we orbit around the sun," that's technically correct, but because that center of mass is sort of inside the sun, but the sun also does a little wobble. And so as the sun orbits around that point, and just as the star sort of wobbles around that point, the starlight changes ever so slightly. As the star moves away from us, it gets a little bit redder. As it moves towards us, that starlight gets a little bit bluer. And so we see this wobbling backwards and forwards, and then through that wobble, we can actually determine the mass of that planet. So the bigger the wobble, the more massive the planet. The smaller the wobble, the less massive the planet is. And then through those two methods alone, we've got the radius and mass of the planet. And from that, you can work out a bulk density. You can work out, well, what are these planets actually made out of? Are these planets made out of pure iron? Are these planets made out of cotton candy? And so the sort of research that I get to do is to actually work out the chemical constituents of those stars, and then use the chemical constituents and look at the elements, say magnesium and silicon and iron, that's inside of those stars, to work out how much magnesium and silicon and iron would be in those terrestrial worlds, to break down, well, instead of saying, well, this could be a rocky world, or this could be a iron-rich world, say, okay, well, the iron core would be this thick, and the mantle could be comprised of these silicates, and then it might have an ocean of this depth. And to sort of really break down and try and work out, are these things Earth-like, or may they be comprised of some other sort of geology? So that's the sort of research that I get to do. And this is all coming from starlight from that star. So this isn't coming from the planet itself. I mean, there's some information that you can get with other transits to get the atmospheric composition of those worlds. But yeah, we're not just pointing the telescope at the star and be like, hey, we found the planet, and there's little green fellas waving a flag there saying g'day. It's not that simple, as much as I'd like it to be.
I mean, do you also, or is part of this sort of understanding or confirming or getting an understanding of the distance of these planets to us as well? Because one thing that, and I mean, this, so this is me coming from sort of this very simpleton sort of perspective of it all, and just getting little bits and pieces of information over the years. But one thing that I always hear is they talk about sort of starlight that comes through, and that light's been traveling for however many years, and by the time it hits us, potentially, or there's an argument that planet may not even exist anymore, that star may not exist anymore, and that light's just been traveling for that long. Is that something that's taken into consideration as far as when you're going through these sort of observations, that you're sort of also determining potentially the distance, but also maybe even the age of a star or a planet?
Yeah, that's an awesome question. And I was having a sort of midnight picnic with my partner about 2 months ago, and we were just sitting on the picnic rug. We were in a field just outside of Toowoomba, just looking up in the night sky, and it hit me that, as you said, these stars are light years away, and so if something's 10 light years away, we're seeing it as it was 10 years ago, because it takes light 10 years to get from that star to us. And it hit me that we can predict these transit events, this shadow pass out of the planet that's being cast across the surface of that star, and we can predict these things to the minute. And so you're seeing, I mean, there's stars that you can see in the night sky that are tens, hundreds, thousands of light years away from us. And the most extreme case, this planet already transited its star like 1,000 years ago, but we're actually seeing it right now. And that just blew my mind to no end. And so, yeah, even as someone studying the field, you're still in awe of it all. And I mean, for the brightest stars, it might be the case that a few of them may have supernovae, but the supernova rate in our galaxy is about one supernova event per 100 years. And so some of the stars in the night sky may have supernovae, but it's very, very unlikely that the stars that we see in the night sky have exploded. So for the vast majority of them, they're there, and we have pretty good confidence that they're still there.
Yeah, because I think, oh man, imagine like spending this time sort of trying to understand, a particular planet, and you're sort of going through all these calculations to try and work out, what's it made up of, and sort of working out potentially, what's the composition of this planet, and then sort of realizing that this planet potentially doesn't exist anymore. It's gone, and you've just been sort of investing all this time and fantasizing about this amazing discovery, and then just go, oh, actually, no, we'll have to move on to the next one now. So,
well, one planet that I have helped discover, which is really, really cool. It's called HD 76920b. So it just rolls off the tongue. And this thing behaves more like a comet in our own solar system than a planet. And so it has an incredibly oval or elliptical orbit. And if you were to place it into our own solar system at its closest point, it would more or less graze past the sun's atmosphere. And then at its furthest point, it would be between Mars and Jupiter. And so this planet is very, very peculiar in the sense that its star that it orbits around is 7 billion years old. And we can use that starlight to actually help determine the age of the star. And over time, the interactions between that star and that planet should even out and circularize that orbit. However, it hasn't. And so we were wondering, just like, our ScoMo's our prime minister, was like, well, how did he get here? How did that planet get there?
Well played.
There's a couple of theories, and it may be that there was some sort of gravitational interaction between the planets within their own planetary system, and all of a sudden, this planet's about 3 times more massive than Jupiter. It said, nah, mate, I'm coming in like a bowling ball, and then just sort of pass through its siblings' orbits, and in this case would have just sort of spewed them out into the cosmos. And so that's how sort of rogue planets, these planets that don't have any star to call home, may be born. And so there may have just been, sort of that gravitational interaction between these planets that just sort of scattered out all these planets and just left this huge planet orbiting around this evolved star. And this star is slowly becoming bigger and bigger as it ages. And so within, say, the next 100 million years or so, this planet will actually be engulfed by the stellar atmosphere. So not a good time to be living on HD 76920B, that's for sure.
You should get that tattooed.
I should. It's atrocious. I mean, the names make sense to astronomers in terms of you might see a long string of numbers and you think, oh, well, that's a bit silly, but it's actually the coordinates of the star. And in particular, HD 769. I mean, even I get confused sometimes. 76920. So HD means the Henry Draper catalog, and so there's an observatory over in America called the Henry Draper Observatory, and back in the early 1900s, they created a catalog, and so the first star that was observed was HD1, and then HD2, and then so a HD 76920 would be the 76,920th star observed with the Henry Draper Observatory in that particular catalog.
Wow. I mean, I mentioned before, sort of trying to grasp sort of using the word size doesn't even sort of really sort of give enough weight to sort of what we're dealing with, or what surrounds us as a planet. It's hard to comprehend. Do you find that obviously through science and all these different sciences coming together to try and sort of, as you said, it's not just one sort of field that's going to find all the answers. It's going to be a collection of people coming together with different backgrounds to be able to sort of work out a lot of these answers. But do you find that in most cases there's a predictability to a lot of the universe that we know, as far as patterns and with our own laws of physics and the things that we've learned, that we can sort of predict a large amount of things? Or is there still a large element of this real sort of unknown, unpredictable sort of aspect to the universe, which we're still trying to just absolutely get our head around?
Definitely the latter, man. I mean, so just going on to a different sort of topic in astrophysics, cosmology, everything that you can see around you right now, my shed, Ben Skywalker and his entourage here, and everything you can see around you makes up only 5% of the entire universe. And so there's about 35% or so is dark matter, and 60 to 65% is known as dark energy. And these two, both dark matter and dark energy, was discovered about 25 odd years ago. And even to this day, we have no idea what dark matter or dark energy is comprised of. There's been all sorts of theories and all sorts of observations being made, but we are no further from trying to find the answers to those questions. And so it's mind-boggling. I think that's 95% of the entire universe that we just can't account for right now. And in terms of exoplanetary science, we haven't found a single planetary system out there that resembles our own. The most popular planet that we've discovered thus far is these super Earths, and even more so planets known as mini Neptunes. So they're these bigger gassy worlds in between super Earths and Neptune-sized worlds. And so they're the most populous planet in our galaxy. But we don't have those planets within our own solar system. I mean, we have these planets that behave like comets. We discovered planets that have orbital periods of days or if not hours around their home around their home stars. And it's so unpredictable, dude. And that's what I love so much about being in this field, is that, I mean, yes, we're trying to find an Earth-like planet, but it's not as simple as saying, okay, well, this star sort of looks like the right type of star to host an Earth. Let's go check that out. And so you check out the star, and it turns out that it doesn't have an Earth-like planet at all. It has these, it might have 2 or 3 huge Neptunian like planets. It might have a large Jupiter planet between them, or it might be in some other sort of configuration. And there's just such a large diversity out there of exoplanets, and it just makes it so exciting. And then trying to answer the question of, is Earth unique, or is the solar system unique? And right now the answer is yes, they are very, very unique. But maybe in the next 10, 20, 50 odd years, that answer might change.
Well, I had, a couple of years ago, I had Professor Tamara Davis on the podcast.
Legend. Yeah. Absolute legend.
And she was, a lot of her work, from what I could recall, was around sort of just trying to, wrap our heads around collectively about what dark energy and dark matter is. And she was going through this, explaining a lot of this stuff, and I'm just sitting there in front of her, because I met up with her and did it in person, and I'm just sitting there and just trying to look like I could follow what she was talking about. And I'm just like, oh my God, like, I don't know how she sleeps, just because, as you said before, that in itself is such a it's a majority of everything. And as it's an unknown, it's like having, I don't know, I'm just trying to think of a comparison. It's like sort of having a puzzle, and you've only just put in one corner of the puzzle, and that's it. And the rest of the puzzle, you've just got no idea. You've got nothing else to work with. And it's absolutely incredible to see sort of, I guess, what could be known or what could be discovered when we sort of answer some of these massive questions.
But that's the essence of science right there, Andy, is that if we knew the answers, we wouldn't be doing science in the first place.
Oh, yeah,
no, sorry, that sounded a bit condescending. I apologize.
No, not at all.
But that's what makes it so exciting. That's what sort of gives me the energy to do what I do, because you never know what you're going to discover. You never know what you're going to find. And what's great about astronomy is that, and astrophysics in some degree as well, is that it's an observational science. And so as much as it would be great to sort of have a little sandbox in your lab and create planets and destroy planets and say, all right, well, what sort of conditions can we create in the lab that could create an Earth-like planet? And you can do computer simulations, and you can do models and whatnot, but it's not the same as actually doing it in situ and being in person. Like, for example, biology, you've got the microbes in front of you right there in order to play around with. But for us astronomers, it's not that easy to drag planets around, unfortunately. So it's just a matter of pointing the telescope out there and just seeing what you can get. One of the most famous images to ever come out of Hubble is known as the Hubble Deep Field image. And so this is just a patch of the night sky, the sort of similar size to the moon in the sky. And they just did it for shits and gigs, man. They're like, let's just point the telescope in this dark region of space for 30 days, and let's just see what happens. And sure enough, they waste 30 days, or what they thought would wasted about 30 days worth of observing time. And they took a picture of some of the most distant galaxies we've ever photographed. And it was that one picture alone that helped us to estimate how many galaxies there are within our own universe. We could measure the redshift, which can tell us how far away these galaxies are. And these were some of the first galaxies to ever be formed in our universe. And this just all came from, people in charge of the Hubble Space Telescope being like, well, let's just do it and see what happens. And that's what I love about science, man. It's just the unknown. And you can always prepare yourself for it, and you can always do your best to try and find what you're after. But sometimes it's just those sort of surprises that get you and go, well, why is it like that? Why is it that the most popular planet in our galaxy doesn't even exist in our solar system? And definitely keeps me up at night sometimes, man, but it gets me excited as well.
As you learn more and you start to sort of, on your own path, going through all your studies and your interest in this field and what you're doing now, is there, how do you digest everything as far as what your role is in the grand scheme of things being, you know, this speck in the universe. Because I mean, when I first started, you know, finding an interest in a very sort of casual, ultra casual way, but, you know, just sort of listening to all these like really cool facts and pieces of information that are quite exciting about the universe, and sort of people trying to articulate the scale and the size, and you sort of, it's very humbling in a way, because you sort of just realize, oh my God, like I'm, you know, not to sound negative, but it's like I'm nothing. I'm absolutely nothing in comparison to what is ultimately around us. Have you sort of had to go through that stuff yourself? I mean, how do you sort of look at you and your existence versus everything else?
Excellent question, man. And yeah, like you say, the scale of the things, especially the universe, is just so grand, and I mean, we're just primitive monkeys to an extent. I mean, if you picture in your head the difference between, say, 1 million and 1 billion, you can't do it. The same as, say, the difference between 200,000 and 400,000. Like, it's really hard to conceptualize. And I mean, yeah, the universe is grand. And ever since I was a kid, I reckon I was about 7, and my parents were watching Time Machine on TV, and that scared I mean, that was the first time I sort of came face to face with my own morality. And ever since then, like, I've been really anxious about time, and I even go to a psychologist now for it to help me with my anxiety around it. But the point of just like, when does it stop, is a pretty scary thought. But in terms of us being sort of insignificant or small, I don't see it like that. I see it as, and everything around you, the calcium in your bones, the iron in the nails that hold up your house. I mean, all of this stuff was forged in the center of a star that was born billions of years ago. And I mean, to sort of quote the likes of deGrasse Tyson and Sagan, you know, we're a way for the universe to know itself. And what's more awesome than that, man? I mean, the universe began with just helium and mostly hydrogen, and a little bit helium, but all the heavy stuff was forged in the center of stars, or in violent explosions where the star goes supernova, or sometimes it's the merger of, especially the heavier stuff like gold, is formed when two dense stars collide with one another. And all of that stuff is around us and is inside of us. And I mean, what could make you any more special than thinking that you are a part of the universe, and you're just trying to learn more about yourself than we knew, you know, only yesterday or the day before.
It'd definitely take, you know, you mentioned before about, you know, just sort of managing anxiety, which I could completely understand, especially when you're dealing with what you're dealing with. But I mean, no doubt that would be such a great sort of answer to a lot of those feelings that you would no doubt have, because, you know, it would give some really healthy perspective, you know, of you know, not so much purpose or anything like. Well, I guess it is purpose in a way, because, you know, we're part of it, you know, we're an element of it, and every element is critical to everything else around it. You know, it all plays a part. It's all intertwined together in its own unique way. And I guess when you sort of look at it that way, then, as you said, like, everybody's, as corny as it might sound, like, everybody's special. Everybody's, you know, got stardust in them, so to speak.
Yes. But I mean, when you're faced with day-to-day challenges, it might not seem like that. And so, yeah, for me, sometimes it's just a matter of slowing down and having those sorts of internal conversations. But yeah, I don't know what else to say, man. It's just super profounding to think that we are a part of the universe, and like, yeah, like, depending upon your your belief systems or whatnot. I mean, we've been around for a very, very long time, and will continue to be around for a very, very long time. So even though your consciousness might not still be here, all the atoms that make you are still here on Earth. So it's really weird to think about, because I often think about, well, what part of me is like recycled dinosaur or like a recycled plant like millions or billions of years ago? Yeah, and I'm sure someone's done a study out there in terms of, you know, what sort of recycled material you are. And I mean, because the atoms just don't disappear. They just get repurposed. And so, yeah, those atoms were here thousands, millions of years before I became to be, and will continue to be here for another thousands, millions, billions of years after my conscious finishes its time on this earth.
I love the idea of like sort of what part of me's got some dinosaur in me. I'll just be thinking of next time I'm like doing something really ridiculous, like, you know, or ridiculously sort of trivial, like, you know, clipping my toenails, to be like, oh, that's a velociraptor toenail that I'm just clipping off. But I mean, I think, you know, I mean, I won't sort of go down this rabbit hole, but, you know, you just mentioned really briefly about depending on people's belief systems. I think for me, you know, just personally, I sort of, you know, I think I sort of look at a lot of people and a lot of things that people believe. There's a common theme around sort of, well, for not everything, but a common theme with a lot of belief systems, that there's an ultimate fear of death, and there's things that need to be done in order to wipe the slate clean, or ensure that, you know, whatever is going to happen afterwards, you're taking care of, whatever that might mean. And I think for me, like, one of the things that I find really sort of, it gives me peace of mind and sort of settles my own mind, is that, you know, ultimately, as you said before, like, you know, we're made up of what's been in the past, and when we go, we will go back into the earth, or we'll become we're still part of the universe. We're just in a different formation, lack of a better term, and we continue on, even though sort of that conscious element, our consciousness is no longer there. But you know, I kind of like that. I like the idea that, you know, ultimately, and, you know, for all of us that have had, you know, family members or friends, close ones that have passed on, I think, you know, everyone's got their own ways of dealing with that. But I kind of like the idea that people are still, you know, ultimately, you know, that carbon's out there. They're part of the universe still, no matter what. And it's sort of almost like this sense of purpose, you know, where we're still being productive, even though we're not here anymore.
That's right. And I guess in the great words of Mufasa, it's the circle of life.
I wasn't expecting a Lion King reference, but I'm glad you were able to slip that one in.
We're here now, man. We're here now.
Where does all this come from? You know, you mentioned sort of, you know, being a kid and sort of first sort of getting scared about sort of, you know, all this sort of stuff and sort of digesting this information. But, you know, did you go through these phases as a kid, wanting to do different things, and ultimately sort of fell into this sort of field where you thought, oh, well, I'll give this a shot? Or has this always been sort of this underlying passion where you sort of felt that eventually you'll be doing something like this down the track?
Oh, I think a little bit of both, Andy. I mean, ever since I was a kid, I've always had a fascination with space. And I'm coming from Adelaide, and being a kid at the time, you had the likes of Dr. Andy Thomas, that was a part of the International Space Station. And so I would wake up, my father, I grew up in a pretty, I grew up in a character building suburb of Adelaide. Oh yeah. known as Salisbury. So you can go look that up and look up parodies around that. But so yeah, I'd wake up my parents at 2-3 o'clock in the morning, and so my dad would wake up with little beady eyes and go, well, what's going on? And I'm like, I just want to wave to Andy. And so we go outside, and I mean, it's silly at the now that I think about it. I mean, satellites, you're better off seeing them between nearing to sunset and sunrise, just due to the angle of the sun and whatnot. So when it's in the middle of the night, you're not waving to anything, but that's not the purpose of it, right? It's all about inspiration. And so my dad would be like, all right, well, let's go. We go outside, and I would, wave to Andy Thomas, just thinking maybe one day he'll spot me, but probably not the case. But when I was in high school, I had this sort of dream as when I was in primary school, and I wanted to be an astronaut. And then that sort of, when I got to high school, I wouldn't say the interest wasn't there, but I just got interested in sort of different things. And I joined up the Army Cadets when I was in year 8. And I really enjoyed that. And so I wanted to go to ADFA and become an officer. And then I got to year 12, and I sort of talked myself out of going into the Defence Force. And sort of in between that time as well, I was thinking, well, I could be a pilot and then become an astronaut, and then found out that I'm too tall to do that. So
right. What's the height limit?
I think it was, at the time, I think it's about 6'1"-ish.
Right.
And I'm 6'4".
Okay.
So it just depends upon the design of the cockpit more than anything else. You don't want your knees to be taken out when you need to eject out of the plane for whatever reason. That would be a bad time. Yeah. So it got to, and I failed year 12 as well, due to I just going through bad episode of anxiety at the time. So I did year 12 over 2 years, and it got to the last day of actually picking courses for uni, and I was thinking, well, what the hell do I do? And so I was like, well, I like physics, and as a kid growing up, I loved space, so let's just type in space physics. And so
ding ding ding.
I looked that up, and there was space science and astrophysics at Adelaide, and so I'm like, hell yeah, I'll just do it and see what happens. And I got in, thankfully, and uni was really hard because I'm a first generation uni student. I think in the at least 5 generations, probably even more, from either side of the family to think about finishing school, let alone go to uni. And so it was really, really tough for me. And I remember I didn't get good enough grades in my first semester, and the head of astrophysics at the time, he sent me an email saying, hey, look, I really want to chat to you. And so he pulled me into his office, and he said, look, Jake, like, your scores for this semester weren't too crash hot. I don't want to scare you, but you should probably think about doing something else. And man, that completely motivates me when people say stuff like that, because I said, well, no, I'm going to prove you wrong. And sure enough, I think I have. So, I sort of got into loving exoplanets. I think in first year, we got an iPad, the first generation iPad. So it was a pretty big deal at the time. And there was an exoplanet app, and you get a notification every time there was a brand new exoplanet. And I didn't have internet at home at the time. And so I get notified as soon as I come into uni. So I'd get excited, get on the train, get in, and then see, okay, well, there's one discovered this week. And so I'd look up about it and then see who discovered it. And I'm thinking, wouldn't it be cool to be a person that discovers a world beyond our solar system? And then my honors was in atmospheric physics, shooting lasers in Antarctica and seeing what comes back.
That sounds like fun.
That's what happened. Unfortunately, I didn't get to do it. I just analyzed the data, but that does sound like a good time. And so that's looking at clouds that form in the cold winter, and in the stratosphere, it'd be about minus 200 degrees. And so there's these clouds of nitric acid and sulfuric acid that form. And so when the spring comes, because you have winter down in Antarctica, is almost night. And so as the sun pops up, that emits UV rays, which sort of disassociate the atoms within those clouds and deplete ozone. And so it's pretty important to understand that. And then I got to the end of honors and thought, I couldn't study another degree in my life. Like, I'm done. That's it. And so I was working in a nightclub during my undergrad and working at Radio Adelaide doing a heavy metal show. But got to doing like bar work, and I thought, all right, well, just do bar work for this year and just think about what I'm going to do next. And then I got to about July, and I'm like, no, I can't do this for the rest of my life. I need to go back to uni. And so I saw on Science Alert, which is a sort of science news website, on their Facebook group, on their Facebook, and it said, run away and join the circus. Get your master's in science communication and be a part of Questicon's science circus. And I'm like, what the hell's a Questacon?
Sounds ultra nerdy.
Yeah. And coming from Adelaide, I mean, most people on the eastern seaboard would know what Questacon is, as you go to it on a year 6 camp. But for me, I had no idea what it was, and so I just applied because I thought it sounded cool. And so I got in. They flew us over, and I'm like 24 at the time, and I had my first trip to Questacon, and holy shit, I was a kid in a candy store. It's amazing. So cool. So for people that don't know what Questacon is, it's a National Science and Technology Center, and it's a huge sort of interactive science museum. And so you can play air hockey with a robot and, jump 5 meters down a slide and not break your neck due to physics, and all sorts of cool fun. So I'm like, yeah, this is what I want to do. And so that's where I got my sort of science communication training, and got to travel around in different parts of Australia presenting science shows to kids. And then after that, I was like, well, I want to get back into research, and here I am.
Wow. I mean, going back to what you said before, actually, that's funny because I did see that you were, or are you still getting out there and sort of doing that stuff with high schools and primary school students?
Yeah. So I just finished up a grant up here where I was going to schools in low socioeconomic areas, because that's sort of my jam. And the workshops are aimed at preppies, so kindergarten to grade 2s, and getting them to sort of dance through the solar system and build alien worlds out of Play-Doh. And oh man, I have so much fun doing that. I don't know who has more fun, the kids or me.
Well, I was just thinking earlier when you were talking about, I think you were giving sort of a comparison of how, and I'm even going to stuff this up, I should have written it down, but how you were sort of measuring or sort of discovering these planets, and you were giving some comparisons. Yeah, the elephant. And yeah. And I was just thinking, oh, that sounds like this would be the perfect sort of examples to give, like, kids in primary school or even high school, these examples, so that it's relative to them and they can digest it and sort of, draw a link of interest into ultimately what you're doing.
So you've just caught me. That's basically it, dude. I mean, it's all about being relevant and being relatable. I mean, you just can't go into a classroom and start talking about planetary dynamics and giving kids first year university calculus. I mean, that'd be a little bit silly. So you're going to make it.
You can't even do it with adults. You can't even do it with me. I struggle with just the simple examples, and I'm still going, I think I've got that. Maybe. I don't know. Well, anyway, I'll pretend and just keep rolling with it.
But that frustrates me, because as the lecturer, or as the person that's presenting that information, you should know who your audience is. And if I can distill down my entire master's course in science communication, that's it. It's just know your audience and try and be relatable and try and be relevant to that audience, and just make things fun and engaging. And when I try and create things for students or for anyone, whether it's talking to a group of metalheads or whether it's talking to a group of preppies, in some cases they might have the sort of same mental capacity, and some metalheads shots fired. But like,
hey man, I'm not putting up an argument whatsoever. People have been listening to this podcast for years. I've had my moments. I'm sure someone who has a lot of time on their hands could pull out a show reel of every time I've taken a jab at my fellow metalhead community. So yeah, no, that's fine. No, yeah.
But you're just gonna make it fun. Like, yeah, I think about making it fun and making it engaging, and then afterwards, if someone learns something from it, then that's great. But it's all about changing people's attitudes around science, and that's the sort of science communication I want to do. I want to get into a classroom, and what I find the kid that has this face of, I hate science, I don't want to be here. And I've had examples like that where kids at the start are like, science isn't my jam. And as soon as I hear that, I'm like, you're mine. And because by the end of it, they're like, actually, that was kind of cool. Or after it, they'd be like, that was fucking sick. Like, I now want to learn more about it. And I want to just sort of plant the seed. And that's what I try and do as a part of my science communication, is just make it fun and exciting and planting that seed. So, and then sort of giving them resources so when they get out of the classroom or when they've finished that sort of lecture, go away and be like, oh, what else can I learn from that area, or what else can I do in my spare time to sort of increase my knowledge and awareness of that particular topic.
I guess ultimately you've got to, people like yourself have got to get out there and inspire that next wave, that next generation of kids that, develop an interest in these different fields and hopefully make a difference themselves when they come of age to make decisions of, extra education or going into a professional field or, field of study. And you sort of don't want it to fizzle out, so to speak. You want it to continue to expand and grow. And it's like the sort of that exponential, progress that humanity's made over the past, 100 years or 50 years in particular, and you want that to continue to move in the right direction. So it's critical that, that interest is there, and it's exciting, and especially when you've got young people, and it's not even young people. It's not only young people. It's the general public who, your everyday person just would probably glaze over at a lot of this stuff if it's just spoken about in its sort of technical terms. But if it's in a digestible way, it becomes exciting and inspiring and interesting, and it gives people a bit more of an open mind to sort of accept things that are being discussed in the public domain, and hopefully more and more people are out there talking about it.
And you've hit it right on the head, man. I mean, like, in terms of what I do, I don't want every kid to be an astrophysicist. I don't want them to steal my job. But it's not about making sure that we have, obviously we want to have bright minds in Australia. We want to keep our STEM force in Australia. A lot of the times, especially in the current situation that we're in Australia, where research funding is decreasing all the time, is that we got to go elsewhere, and your brightest minds need to go elsewhere to make a living. And so, if you have a society in which accepts and acknowledges what science and what STEM can actually bring to society, is awesome. And so I just really want to hope and then sort of create a society where we are not scared of science and we're not scared of technology. The sentence of, well, I wasn't never a math person, or science sort of scares me. I don't want that. I don't want that to be the case, because then you get people that can be misinformed and can be led astray, and that's when the voting public can make some ill-informed decisions, which can then affect us all. I
think it's a massive thing that maybe it's like anything. When you're more in tune to something, you start to notice it a lot more. But I see STEM being discussed and sort of highlighted and celebrated more so than ever. And to be honest, probably a couple of years ago, I wouldn't even know what the hell any of that means. And so that's probably a win in itself, that if I'm more aware. But I think a big thing that is just so important, and I think is so underrated because people just don't think about it that often, is communication and education, in the sense that you have to win people over and appeal to them in a way that it makes sense for them. And, whether that be on a baseline of just pure entertainment and entertaining people so that they are more open-minded to a concept, or it might be, putting it in a scenario that is relative to their own everyday life, so then they're able to relate to that and understand and appreciate it. And where it all fails is when, from politics and social topics that are out there, is that we're all very quick to sort of point a finger and blame or tell people that they're wrong or that they don't know what they're talking about, when really, if we took a different approach and started to sort of appreciate or show sort of a little bit of compassion to see where other people are coming from, because not everyone's been exposed to the same amount of information. So you say, well, totally appreciate where you're coming from, and these are some other things to consider, and formulating it in a way that's appealing to that individual, rather than sort of this mass sort of piece of information that's meant to be diluted for a large sum of people. Because I mean, when you're speaking about sort of the approach that you take with school kids, I mean, I remember being in school. I mean, I glazed over in almost every subject that I attended in high school. I was just an absolute borderline dropout, and I think a lot of that was I didn't realize until I was in my 20s, where I really sort of had this light bulb moment where I thought, and it sounds so ridiculous when you verbalize it, but I sort of looked at it and go, wow, it's actually fun to learn things. Like it's interesting to discover things, bits of information, and read stuff and watch documentaries, and just, whether it's relative or not to yourself, or it's going to be practical, it sort of doesn't matter sort of in the short term, because it's just this sort of opening the world up to learning and just appreciating what's around you and discovering all these little treasures. And if that was sort of pitched to me in school and it was delivered in a way that was a little bit more digestible for me and my little stubborn, rebellious nature that I kept putting out there, who knows? I mean, I could have left my sort of education going in a different path than what I did, and I'm certainly happy with where I've ended up. But it's very easy for me to sort of appreciate sort of what those challenges are for kids, because I'll put my hand up, been there, done that. It's really hard when you've got somebody just basically telling me what I need to learn and not really explaining to me why it's good for me to know it, not I have to know it because that's just what I need to know.
Yeah, and I mean, you've touched on a lot of talking points there, and a lot of it you're preaching to the choir here. But in terms of teachers, you always, I mean, you can think of the inspiring teachers, but most of the time you always just think about the bad ones, and it's always just that one bad teacher that gives you that negative experience that then just, for example, you might have a science teacher, your first science lesson, they were a bit disinterested, or they didn't sort of captivate you in the way that you need to be engaged. You're like, well, nah, this isn't for me. Where, maybe 5-10 years down the track, you go, wow, actually that is sort of really cool. And I mean, the fact is that in Australia, teachers are severely overworked and underpaid, and just I've got a few friends that are currently teachers, and just the workload that they have is ridiculous. I mean, these people are working most weekends, they're working till late at night, just to make sure that they've got all the lesson plans up to date. And I mean, to invest in education, you're never losing money. And I wish other people could see the value in that, because when you have a more educated society, you have a more productive society, and you have a more economically sustainable society as well, because they're the ones that are creative, that are inventive, and have that knowledge base to go out and create a future for us all. And in terms of what you said about the current sort of climate that we're in, and if someone's got a differing opinion to you, you just sort of shut them down, or it's just a matter of who can scream the loudest. And I mean, I've been thinking about that for months, man. And the art of debate has been lost completely and utterly. And you can sort of draw a blame on a few factors, but I guess in the main part, you've got social media, where social media can act as an echo chamber. And I, for one, have people on my Facebook who I don't agree with at all in most things, but I have them there to sort of not have that echo chamber, and to think, instead of saying to them, well, you're a big dum-dum, because I mean, if someone comes up to you, Andy, and if you have a differing opinion, if they say to you, well, you're just a dumb idiot, like, who are you? Like, that doesn't help. You're not going to turn around and be like, yeah, that was a fair point. I'm gonna agree with you now. Like,
yeah, that's exactly right.
That would never ever work in a social situation. So why does it work on the internet? And so, yeah, just having more compassion. And the way that I think about it is, what got people to that point where they think like that? What sort of events would have led them to that point where they think that climate change isn't driven by human-made activities? Or why do people think that the world is only 6,000 years old? Or why do they think that the world is flat, instead of saying, well, they're idiots? I mean, for the most part, they're just ill-informed. I mean, in some cases, the Dunning-Kruger effect is well and truly there too. But just to go into an argument and just say, well, and just throw profanity and just curse at people and degrade them, that's just not going to win people over. And you need to be understanding, and you need to be compassionate. But I mean, there's also some issues where we just don't have the time to be compassionate and to be understanding. And I mean, one part of that is climate change, man. Like, we're already, the list of effects that we're already seeing across the world is just 10 miles long now, and we're still discussing whether or not it's real. And I mean, it should have never become, I mean, obviously there's money and greed in there that makes it a political issue, but it should never be the case. I mean, we don't debate in public whether or not the laws of gravity are real. We don't discuss whether the laws of thermodynamics or Darwin's theory of evolution is right. I mean, well, some people do for their own own benefits, but for the most part, like, it's just scientists discussing with themselves who are experts in that field. And if I take my car to a mechanic shop and they're like, well, mate, your car's stuffed for this reason, I'm like, all right, I trust you. You're the expert. I get it fixed. Job done. And the sort of argument that I make about climate change is that, I mean, you got 99.7% of the climate scientists agreeing that climate change is human caused. So that would be like me taking my car to 1,000 mechanics. So you think about how far you would need to go in your local area in order to find the opinion of 1,000 mechanics. And all bar 3 tell you your car is stuffed. Say, for example, your engine's about to cease because you have hardly any oil in there. Well, if there was 2 mechanics that you're taking it to, and both of them said that's what you need to do, then you should go do it. If 997 of them say go and do it, and all bar 3 say, nah, mate, your car's fine, like, you're an idiot. You're a goof. I mean, that completely contradicts what I just said 2 minutes ago. But like, it's just a waste of energy, man, to be like, well, no, I'm not gonna believe you. I'm just gonna go and just drive my car around, and another couple of weeks your engine ceases up and you need to buy a new car. But we can't just go out and buy a new car. We just can't go out and find a new planet. And I mean, as much as I love my field, like you said earlier, I mean, these distances are just so grand that with the current technology that we have, the nearest star to us would take tens of thousands, if not hundreds of thousands of years to get to with the current technology that we have. We just can't pack up and leave. And so there is no planet B. We just can't pack up and leave. Like, we need to look after the world that we live on right now. And I mean, our ancestors have been doing that for millions of years. So why are we the ones to be like, well, no, sorry, we'll just pack it in now?
We're such a weird beast, as it stands now in humanity, because it's only been sort of in the last 100 years the last 50 years where the new wave has come through with technology, and that this exponential progress of humanity and everything that we're sort of our lives are revolved around technology now. And at the turn of the century was sort of the industrial revolution that kicked in, etc. But I think we're still trying to work it out, and I think we're such flawed creatures in the sense that we're very tribal, very emotionally driven, and very we work on sort of immediate gratification. We're looking for things that will immediately sort of serve us rather than thinking long term. It's sort of not programmed in us to sort of be thinking long term or strategizing, down the track, or especially sort of generational. It's very hard for people to sort of naturally have that. And so it's so easy for people to fall into the trap of following whatever your tribe says, jumping on the bandwagon with a particular narrative. And especially where, I noticed in the last election that we had in Australia, where, you had these polarizing, what appeared to be polarizing parties with polarizing stereotypical sort of demographics of people, going at each other, and as you said earlier, like, who can scream the loudest. And it was a big class sort of fight between potentially, and I'm oversimplifying this, of course, but almost this sort of white collar versus blue collar in some respects, and basically from a blue collar point of view, looking at these pretentious people that have got money and think that they're all smart and they're educated, etc., telling us what we should be doing. And then on the flip side, everybody else, on the other side of the fence going, well, look at a bunch of these, sort of bigots or bogans or hillbillies and racists and all this sort of stuff. And once again, oversimplifying, but we were sort of just attacking each other and sitting on our own side of the fence as being these sort of tribal sort of, these tribes going at each other. And I sort of just looked at it and go, man, like, I get why people make the decisions that they make. It's, yes, on both sides of the fence, ill-informed in particular aspects, and very emotionally driven, and very sort of selfish in their agendas, because ultimately they're pushing their own agenda, whatever that might be. And some of those agendas might mean positive things in the grand scheme of things, but it's still, a lot of the motivations are very selfish. And so I just look and I go, man, like, how do you win over? So if you've got an argument about climate change, how do you win over the person who their knee-jerk reaction is to say, well, I don't want some hippie from Melbourne or the inner city of a capital city who what's all those stereotypes, like has the avocado on toast and lives this
so we don't have a house, man.
Yeah, that's exactly right. All these stereotypes, and go, I don't want somebody like that telling me how to live my life. And I sort of sit there and go, I kind of get it, I'm one of these yuppies that sits in the city, and I do love a bit of avocado, and I love living a good life, and I've got it pretty easy. But I'd hate to be told that I'm wrong, or I've got no idea what I'm talking about, and what I'm doing or what I'm supporting is wrong, and I'm an idiot, or whatever it might be, and just completely belittling me, and especially in a lot of this stuff, social media, it's public domain now. So in the end, we're animals, and when we're pushed, we react irrationally. And so that's why we have so much friction back and forth between people, because no one can sort of go, well, we've got these populations of people that live in these rural areas around the country that their entire existence is based on mining. Their livelihood, they're making their family, their generations, it's their entire existence is based off earning money from an industry that's is negatively impacting the planet. but you can't pull that out from under them or tell them that they're wrong, because how do you win them over? And so I always sort of look at it and go, man, like, there's so many good arguments out there, but ultimately you have to gently move people in a more positive and practical direction that's gonna benefit them individually, not just you need to do the right thing by the planet, because absolutely, but ultimately we all take care of our siblings or our children or our parents or partners or whoever it might be first. I mean, that's our domain, that's our country, and then we sort of look outside and look at our local community, and then we go from there. So you sort of need to start in the grassroots first before you start looking at those bigger pictures. So it's really hard for a lot of people to sort of jump on board when there's just so much yelling from both sides of the fence.
Yeah, and I mean, I think I keep saying this, man. You've got a lot there to unpack, and just
I just waffle on a lot.
No. You hit on a lot of good points, and the failings. The biggest failure of science is that in the last 100-odd years or so, we have been teaching it with zero emotion, and we just sort of it's just purely pushed a needle in. It's one-way information, and it's not a conversation. And we need to get back to the point of giving science emotion and talking about science in an emotive way, and not just giving hard facts. And it was something that I learned during my science communication course, and that there's been numerous studies to say that if two people are on an opposing side, just yelling facts at one another won't change anyone's opinion at all. In fact, it'll actually drive people further into their corner than anything else. And so, and it's just wrapping up on a lot of what I've been talking about. But like you say, you got to be relatable. You got to say, well, I can understand why a person who's a fourth generation coal miner might not be in favor of, say, climate change, because you are impacting upon their livelihood. And especially, I came from a blue collar family where I can remember my mum counting 5 10-cent pieces together on a Tuesday night before payday, and that was extremely. We were the lucky ones to count for a can of beans to feed a family of 5, and I mean, you sort of live from week to week, and you don't need to. You can't worry about things that are going to impact the world in another 5, 10, 25 years, because you're thinking about right now. And I mean, just having a little bit of empathy and thinking about, well, what can we do in these areas, for example, that we can both move away and transition from, get people on side, then transition away so that we go away from fossil fuels, but also empower these communities to give them skill sets that they need for future employment, and maybe create industries around those areas that are completely new and novel, and maybe areas of research that we haven't even dreamed about. But yeah, just to go in and say, well, you're a big dum-dum, and just scream the loudest isn't going to help. And shit, you said something else there that I was really wanted to talk about, and now I've forgotten about it.
Oh, don't worry. I said far too many things. I was just this streaming consciousness. Yeah.
But
I think.
Yeah, go on,
I
man.
think what you're doing with just passing on your knowledge, but framing it in a way that's easily sort of digestible for kids is. I mean, I'm sure you get it, because you've made the decision to do it and you're immersed in it and you do it often. But I think it's so underrated in the grand scheme of things, because people need to be out there and sort of so to speak holding the hand of these next kids coming through to say, look, this is this is like an opportunity, and this is something that can be really good for you, and you can enjoy it.
Yep.
You can feel like you're doing something that's going to make you feel good. You can contribute, you can have an impact, rather than, like for me, woe is me, oh, my poor childhood. But it's like, just going back to the whole, this is the information, this is what you need to learn, and always the kid in the class, and I certainly did it, where you put your hand up and go, but is this information going to be in the test at the end of the term?
Yes.
and purely because that was the way that the information was given to us. It was like, the whole goal of this was to pass the year to go into the next year. It wasn't to become a better person. It wasn't to become fulfilled or enlightened or whatever it might be, and open up your world of possibilities. It was just a case of you've got a series of years ahead of you, and you got to get through them. The quicker you can get through them, the better, and whatever it takes. And so the path of least resistance was always the preferred way, and that's the way many of us unfortunately had to go through school. So it's cool to see that people are sort of looking at it and approaching it from a different angle. So like big props to you, because obviously you get a lot out of it, but it's
oh, hell yeah, man.
It's obviously having an impact on others as well.
Well, the whole reason why I go to the likes of low SES areas is one, that I had no role models around me who were like me in terms of going from a pretty average blue collar area to then going on to university. And you go into these areas, and in some cases, I should say, there is some misinformation or people that might be ill-informed. And so I try and just empower kids to say, look, if you engage and have fun with STEM, then I don't tell them this explicitly, but you can make better informed decisions in the future. And it's all about sort of making learning is for everyone, and actually providing an opportunity for everyone from every single background here in Australia to provide them with the same opportunities that everyone else gets. Perfect example is these workshops that I've been doing around Toowoomba. I went to one school, and it was the first time they've had a scientist in their at their school for at least 5 years, and it was the first time they've had sort of a STEM outreach event like that for 5 years. And that's incredibly sad when you think about sort of other schools within the inner suburbs of Sydney, or maybe inner suburbs of Canberra, where you're blessed to have something like Questacon at your doorstep. And yeah, just being able to provide an opportunity for kids to actually engage and get inspired with STEM from rural areas. And I'd like to one day go out and do some remote stuff, and that's when you have the likes of New South Wales Young Australian of the Year award winner this year, Corey Trutt, who created a company called Deadly Science, and gathers up funds, and then can send books and send telescopes and all sorts of equipment out into remote Indigenous communities. And that's amazing, and that's awesome. And one step up can be people going to these areas and not doing this whole the sort of white savior thing of, oh, look at how good I am, and we'll just sprinkle you with some STEM stuff and walk away. Actually go in there and provide them with tools, and this goes for every, like, a rural remote community, and provide them with tools and an opportunity so that they can do it themselves. And that's ultimately what you want to do. You don't want to keep going out there. You want to empower that community. There's
a lot of science. Going back to what I said before, when you're sort of a little bit more in tune with, something, you tend to see a lot more of it around you. But I get the feeling that there's more opportunities for science communicators out there now than ever before, and I certainly see a lot more of them popping up. And maybe because I'm inclined to start following a lot more of them on Twitter, so to speak. But it seems to be it seems to be something that's growing. And you've done a lot of stuff, and going back to your website and sort of scrolling through everything that you've got on there, I know you've done some media stuff, and you've obviously doing all your stuff with the schools and everything. But do you ultimately want to go in that direction long term, where you sort of sit in that space and maybe sort of obviously, as you said, like sort of extend out to potentially rural areas and sort of give them tools and things to be able to help themselves and get better, not just constantly be out there, but maybe sort of a more sort of national approach where you get a bit more of a public sort of presence. Are they things that you sort of think about as far as what you want to do in the future?
Good question, man. You sort of get to this point in your life where you sort of climbed the mountain, you've ticked all the boxes, and then it's about thinking about what's next, like what's the next mountain to climb. And so, I've done some pretty incredible things in, say, the last 5 years. And if you told me as a 10-year-old kid that I'd have all these amazing opportunities to work with NASA and be able to present my work at MIT to a bunch of NASA scientists, I would have told you you're crazy. Like, I'm just a shit kicker from Salisbury. But to be in that position now is amazing, and to think about what your sort of the stretch goals are from here on in. And I would like to still be a researcher. I love research. I love discovering the unknown, but I also want to empower communities. And so, ultimately, I guess I would like a role as a researcher, doing some amazing research, but also I don't want to be the likes of, say, like Bill Nye or Neil deGrasse Tyson or whatnot, where you're on these sort of big productions. At heart, I just want to be sort of a grassroots communicator. And so that's what's the best thing about science communication is that, as you said, jobs for, I guess, science communicators has grown quite rapidly. You have people that sort of go into schools like I do. You have weather presenters who are, and all other aspects, science communicators as well. You have people that work at museums. You have researchers that also do talks. And the role of a science communicator is very, very broad as to what the sort of job opportunities are. But I'd love to be able to have a world where I can sort of mold and gel the two together. That'd be the dream.
Well, I think people can follow you on the socials and keep an eye out on what you're going to be doing over the months and years to come. And it's been cool to sort of watch a little bit of sort of the things that you've been involved with. And to be honest, I didn't really every once in a while I'd see you pop up in my sort of Twitter feed and I'd be like, oh, okay, that's interesting. And then I'd go and click on your profile and have a bit of a read your description, but I really didn't actually click on your website until about a week or so ago. And then I looked at it and went, oh, wow, like you've really been doing a lot. You're involved in a lot of stuff. And it's incredibly interesting. And it's cool to talk to someone like you that's, you've invested a hell of a lot of your own time and resources, and especially coming from the background that you mentioned, and sort of being at that crossroad where that first year being sort of hinted that maybe this is not for you, and just deciding, well, stuff it, I'm going to give it a go, and sort of making the most of it, and you certainly have. So it's inspiring. I don't think I'm going to be jumping into the sciences anytime soon, but I'm certainly inspired to keep driving forward with what I'm involved with, and knowing that there's so many possibilities out there. So I'll have to chuck a bunch of links in so people can have a sticky beak with all the things that you're involved with, and follow you on Twitter and on Instagram and the rest of it as well.
Well, thanks, man. And I'm more than happy to provide you with links to say what we're doing here at USQ, and what NASA's trying to do in terms of finding worlds beyond our own solar system, and sort of cool little things people can do. There's amazing citizen science projects that are out there. And so, for example, there was a Darwin mechanic that discovered a exoplanet last year in a citizen science project, and I mean, that's pretty wild. I mean, that bloke had no experience in discovering planets until then. And I'll try and find as much as I can to try and, I mean, if people have enjoyed this and go, well, what more can I do, or what more can I study? I'll certainly provide you with all of that, man. And just thank you for providing me with this opportunity. It's just so surreal to think that I'm on a podcast talking about my journey and talking about what I'm doing. I mean, it's so weird to think about that you're in this position, but it's a very privileged position, and I'm very, very grateful for it. So thank you.
Yeah, I hope you enjoyed that one with Jake. If you want to reach out to him and learn a little bit more about his world, you can go to the show notes over at andydowling.net or andysocial.net, or you can click through on your podcast player, or if you've got a pen and paper out, get ready for this URL. Jake, you need a better domain name, but it's jake-clark.github.io. He's also on Twitter. Search for space JAYK, but I'll have everything in the show notes over at andydowling.net, or just click through on your podcast player. You should be able to stab your digits against the screen and click a bunch of clickable links in there and get through to him. And as I say with every episode, reach out to the guests, reach out to Jake, let him know what you thought of the episode. It goes a long way, and it's nice to have the anti-social crowd give a little bit of love to the people that sacrifice a fair bit of their time to cop an ear bashing from yours truly. So it means a hell of a lot. If you want to learn more about me before we depart, andydowling.net's the best place to go. All my shows are on there, all my podcasts, our band Lord, all my social media handles. If you want to donate to the podcast and support me, you can go to paypal.me/andydowlingofficial. And no doubt a bunch of other stuff. If you haven't had enough of my voice, you can also listen to the Crazy Talk episodes that come out every Tuesday morning at 6 a.m. Sydney time. Otherwise, another guest episode coming next week. So until then, folks, take care. Ta-ta.